Okay, well, welcome to the session here this evening. We're going to talk about a few of the energy rating programs that are available throughout Canada, but more specifically in Saskatchewan. And what we're going to be talking about is the involvement of the federal, provincial government, and how they rate houses, how they audit the files, how they audit houses, and the Sunridge Group is involved both in the retrofit area, retrofitting existing houses, but we're also involved in the new home side of things, and there's 3 different programs for new homes, which is what we're going to talk about tonight. Later in May, there's going to be another session on retrofit, the retrofit programs that are out there, so there'll be additional things that are going to concentrate on that. So if you've got an existing house, you want to bring it up to whatever levels you want, whether it be the equilibrium level, whether it just be reducing energy bills, whatever it happens to be. We'll talk about the programs that are out there, the incentives that are out there, and possibly by that point in time the election will be over and we'll maybe have better directions or know a little bit more about what the federal government is going to do in that vein. So we'll sort of leave that open-ended for the time being. About 10 or 20 years ago, the federal government, Natural Resources Canada, came up with the ERS system, the Energy Rating System. That system is applicable to all types of housing, whether it's existing houses or new houses, and what it does is it rates houses on a scale from 0 to 100. Just because it's 0 to 100, it's not like grades in a school where 80% is good and 50% is bad or failing. A very highly efficient new home would rate about 80 on that rating scale. And so it's not a percentage, but it's based on comparing it to a benchmark house, and the rating gets derived from that based on the estimated consumption of the house you're looking at compared to an equivalent house based on some benchmark specifications. So that's how that rating scale is worked out. All houses in that system, in the rating system, are analyzed using software that the federal government has developed over the last 2 to 3 decades, and it's called HOT 2000. And the 3 rating systems that are out there for new houses are EnerGuide for New Homes Ratings, Energy Star for New homes, and R2000. And the LEED program, which we'll talk about at the end of the session here, uses energy as one of the components, and it uses the EnerGuide for New Homes rating as part of that program as well. So there's actually 4 programs in Saskatchewan for new homes. EnerGuide for New Homes ratings, Energy Star for new homes, R2000, and LEED for new homes. So we'll talk a little bit about each of those, but first of all talk about that rating system. So the rating system is a rating for the house as a whole. It's not just for the furnace, it's not just for windows or attic insulation or anything else like that. The HOT 2000 analysis software looks at all of those different components. So as a plan evaluator, we look at the plans and specs, we look at how the wall is built, and we input into the software what the wall area is and how it's built. And it takes into consideration insulation levels, thermal bridging, which are weak points in that system, where the framing members are. It looks at windows and doors, its solar gain, and its heat loss out of those components. Same thing with the attics. It looks at air leakage. We air test every house to find out how leaky or tight it is, and the software then uses that information to determine how much energy is being lost from natural leakage. We also input information regarding the mechanical equipment, things like the ventilation, whether it's got a heat recovery ventilator or not, and how efficient that ventilation system is. It looks at the domestic hot water side of things and how efficient that appliance is, whether it's naturally aspirated, whether it's tankless, whether it's condensing or not. And then it looks at the heating system as well, whether it's geothermal or if it's gas, whether it's condensing, and how efficient it is as well. All of that information together then, along with the size of the house, goes to determine what the rating of the house is. And that's what we can see when we look at this graphic here. This is a graphic that we've developed for Energy Star houses, but it's applicable to all types of housing for that matter. So you can see that we've just got 12 different items on here that we can look at that are basically energy components of a house, or components of the house that have some energy related features to them. The first thing would be the HRV, which is a box in the basement basically that exhausts stale air from the house, brings in fresh air from outside, and while it's doing that, it recovers some of the energy or the heat that's in the air that otherwise you'd be dumping outside and basically losing. So rather than having to heat up the cold air you're bringing in the wintertime and lose the energy from the hot air you're exhausting, there's an exchange there. And typically these units are anywhere from about 60 to 80% efficient. So they save about 60 to 80% of the energy that otherwise you'd be losing outside. Traditional housing typically has exhaust-only fans for ventilation. So they simply come on and they exhaust the stale air and they don't bring in any other air, and it's simply natural leakage where it leaks in all over the place and it's just a dead loss. So that's the heat recovery ventilator, and that typically is located in the basement. They are nice and quiet so that people tend to use them a lot more. Rather than regular exhaust fans, most of us have the experience with exhaust-only fans in the bathroom. They don't move a lot of air, but they make a lot of noise. They're annoying, so people tend not to use them very much, and most of our homes are under-ventilated. Existing houses I'm talking about now. So in new houses, to retrofit an existing house with an HRV is not very easy, but to put it in a new house in the first place makes a whole lot of sense and is the right thing to be doing, because it's a very efficient and effective ventilation system with heat recovery as well. The second item that's showing up on here is number 2, and that's the heating system. And again, if we look at a natural gas furnace, that's the way most houses in Saskatchewan, what they have, is the condensing furnace. High efficiency ones are the ones that are available now. That's about as low as you can go, and they have efficiencies anywhere from about 90 to 96%. And then you can look at some other features with staged burners and high efficiency fans on them to distribute the energy around the house and that sort of thing. This graphic here shows the water heater here as being a tank style, and that's the way what most houses have. For the new housing programs, they need to be power vented or induced draft. That has some degree of safety to it because naturally aspirated water heaters can backdraft quite easily. If the house is under a negative pressure, the weak point is a chimney, and they can tend to backdraft and cause spillage quite easily. So induced draft or power venting are a minimum. Then you can also go to condensing tank water heaters. The next step up though is the tankless water heaters, and they can either be lower efficiency or condensing versions as well. And those tankless water heaters are anywhere from about 82 to about 95% efficient. Okay. Number 4 is duct sealing. Another feature of many of the new housing programs is sealing the ductwork. Most forced air heating systems have supply and return ducts throughout the house. Many of them are quite leaky, so the housing programs require that those duct joints and connections and everything be sealed so that you're not losing air. Granted, it's being in the house, but it's not getting to the areas where the energy is really needed, so they require that the ducts be sealed. The other thing is water-saving appliances. This is certainly highly recommended to reduce the heating load, but again, the less water you can use, the less impact it'll have on the domestic hot water heater. Upgraded wall insulation. As I said a few minutes ago, most walls have framing members that run right through, and there's lots of that's called thermal bridging, because wood has much lower insulating value than insulation. Bad insulation has an R value of about R3 per inch, whereas wood, depending on the moisture content and the species, will have about an R1 per inch. So if you're looking at the traditional way we frame houses in Saskatoon, 2x6 studs, 16 inches on center with R20 bats. Where the insulation is, you have an R value of about an R20, but where the wood is, you have an R value of about 6. So with the percentage of wood framing that's in there, from top plates and bottom plates and jack studs and regular studs and lintels and everything else like that, potentially 20% of your wall area is framing members, which has an R value of 6. So overall, that brings the average wall R value down considerably. Rather than being a real R value of 20, it's probably closer to 15 to 18, somewhere in that range, depending on the spacing of the studs and how you frame corners and intersections and other things like that. So it's important that the exterior walls, because they have such a large area, Typically in a bungalow, 1,000, 1,500 square feet depending on the size of the house, so a significant heat loss can be going through your main walls. Ways of doing that would be to trying to eliminate the thermal bridging by putting foam insulation on the outside, strapping it horizontally so that the insulation that goes into the strapping covers the studs. You can use other non-traditional types of things like SIPs and ICF wall systems. All of those things improve the air tightness, but just as importantly is that they reduce the thermal bridging because there's no direct flow of energy from inside to outside through that wall system. Okay? The second thing, or the number 7 on the list here, is upgraded basement wall insulation. The concept for the basement is the same as it is for the main floors. You want to try and get as much insulation as you can in there without the thermal bridging. You have a little bit more leeway with basement walls below grade because the temperature difference is not as high below grade as it is above grade. Above grade we have plus 20 on the inside to minus 40 on the outside, so our delta T, or our temperature difference, is 60 degrees Celsius in the middle of winter. Whereas once we get below grade, that delta T, or temperature difference, goes from plus 20 inside to maybe freezing or minus 5, or whatever it is outside. The heat loss is directly proportional to the temperature difference. And so below grade, we have a little bit of extra buffering there because our temperatures are not quite so cold. So a little bit, typically you wouldn't need to have quite as much insulation in your basement, but it's easy to do there typically because you usually have the space to do it as well. Okay? Number 8 is upgraded ceiling insulation. Again, we typically see values in the R50 to R60 range. R40 used to be pretty standard 5-10 years ago. R50 and R60 is becoming much more common now. But a couple of extra things to pay attention to is the heights of the heels on the trusses, because as our roof slopes down here at the corners around the perimeter, we typically